In today's lesson, we are going to be looking further at linear relationships. Specifically, we're going to be looking at two-point problems. So just to recall, we have learned before, to determine the slope of a linear relationship, we are finding the rate of change for every step in the relationship. In order to do this, we need to look at how the y values change with respect to how the x values changed. In all the previous examples we've looked at, we did look at a few examples or challenge questions. The change in x values has always been 1. So we found the slope by looking at how the y values were changing in each step. But what if we were given a pattern where the change in x values is something other than 1? So we did look at a few of these challenge questions, and we came up with the formula m, or slope, is equal to the change in y divided by the change in x. And we can write it in a new way. Rather than having to write all that out, we can write delta y over delta x. And all this is really saying, this is just a fancy Greek letter, delta. And all that's saying is just change in y over change in x. So it's not really doing anything different, it's just an easier way to write it. So if we look at these two values, or these examples, we're going to try to find the change in y and the change in x. So, I want to come up with a linear equation, y equals mx plus b. I'm going to try to find my m value. What am I going up by each time? Well, the change in y from 4 to 19 is plus 15. The next one from 19 to 39 is plus 20. And the next one, 39 to 79, is plus 40. So we can see that's inconsistent. Right? We don't see the same values. If I look at the other side, the change in x, I can see I go up by 3, I go up by 4, and then I go up by 8. So again, it's not a consistent increase. So we have to do something a little bit different. And this is the change in y and the change in x. So if I look delta y over delta x, I'm going to use different colors here. Oops. If I look at the change in y and the change in x, right? What is my change in y and change in x? Well, I have multiple options. So let's take a look at the first pair. What are we changing by? Well, our y is changing by 15 over our x, which is changing by 3. 15 over 3 is 5. What if we look at another pair? Oops, if I look at another pair, go through the same process. I get 20 over 4. Change in y is 20, change in x is 4. Oh, that's also 5. Well, what about the last pair? Is that any different? Again, m equals delta y over delta x. We get change in y is 40, change in x is 8. 40 divided by 8, oh, is also 5. So it seems that it doesn't matter which change in y and which change in x I use, as long as it's consistent, I should get the same thing, which makes sense because it's a linear relationship. If it was the same, or if it's a linear relationship, it should be increasing by the same amount. So when I look at different points and I break it down to the simplest, or I reduce it to as simple as possible, it should be the same. The only other thing now, because now we know y equals 5x, we need to find our b value. What is our y-intercept? Well, this one was nice because we can see it here. We can see our y-intercept clearly from our table. We have x is 0, y is 4, so that's our b value. So our equation is going to be y equals 5x plus 4. if we look at the next one, another inconsistent increase. Right? Just looking at this table, we can see it's inconsistent. Let's go change in y and change in x. So delta y from 17 to 75. Might need to break out a calculator. So 75 minus 17. So this is an increase of 58. From 75 to 223, we get a change of plus 148. And then from 223 to negative 3, we get a change of negative 226. Right? So you're looking at how do we get from one y value to the next. If we look at the change in x, from 1 to 30, that's a change of 29. From 30 to 104, that's a change of 74. And from 104 to negative 9, that's a change of negative 113. So what is Rm? What is our slope? Right? Again, if we go through and look at the different steps, right? M, so change in y over change in x. We have multiple changes in y's and changes in x. There's nothing consistent to look at, so I can't look at these and just get an answer. So let's look at the first pair. And you might be able to see a pattern already, but the change in y is 58. The change in x is 29. I can reduce this to 2. I can look at the second pair, or the second change in y and change in x. Go through the same process. 148 divided by 74. Oh, that's 2 as well. And I'm sure you could kind of go guess what the next one's going to be, but if we look at the third pair, change in y over change in x, negative 226 over negative 113, that's 2 as well. So looking at this, it doesn't really matter which pair of points I use, I still get the same m value. Right? I still got an m value of 2 regardless of which pair of points I looked at. So right now I know y equals 2x, and there's going to be a plus b. So I need to figure out what that plus b is. I don't see it in my table, but the nice thing is I do have an x value of 1, so it is relatively easy to work backwards to find this 0 value. So if I work backwards to position 0, and I reverse my pattern, or if I know my pattern is increasing by 1 every time from the m value, I would minus 2 from 17, and I would get back to 15. So that means then that my b value is positive 15. So my equation for this linear relationship in this table is y equals 2x plus 15. Now, the big thing from this is that it doesn't really matter which pair of points, right? We saw that we have basically 3 pairs, right? The first 2, the middle 2, the last 2. Same with the last one. It didn't really matter which pair of points we used. We still got the same multiplier. So the question then becomes, did I really need to find the slope for all those other pairs? Do I even need those other pairs? If it's a table of values and I have those patterns, then yes, I could have it. But do I really need that to solve? Right? And the answer is no. As long as we have 2 points, that's all we really need. So as long as we have 2 points, I don't need to worry about any other ones, and I should have enough information to find the equation of a line. So that's what we're going to focus on the next ones. We're only going to be given 2 points. So here I have 2 points, 5 and 1,000, 10 and 900. Right? I'm going to look at the change in y. From 1,000 to 900, that's a change of minus 100. The change in x from to 10 is a change of plus 5. So my m is going to be change in y over change in x, negative 100 over 5, which is negative 20. Now, to find our b value, which is the second thing, to find the b value, I can reverse the pattern. Because again, I'm going up by 5 every time, and I know what it's changing by, so when I reverse the pattern and go back to 0, I just need to reverse the pattern, so I would add 100. You could go back up, if you didn't recognize that pattern, you could go back up every one step, reverse the multiplier of negative 20, and go up by 20 every time, so to 1,020, 1,040, 1,060, 80, 100. Which is what we would get at step 0, which is our b value. So we have enough information. We have our equation, y equals negative 20x plus 1,100. Just as a secondary option, if you didn't recognize that pattern to find the b value, you could also take a value. So I'm going to take the x value, so 5. I'm going to multiply it by my multiplier, which is negative 20. That gives me negative 100. Negative 100 plus something would have to equal the y value, which is 1,000. So what's the value that I would have to add to negative 100 to find 1,000? It would have to be 1,100. So that is another way you could go through and solve for that missing value. Essentially, you're plugging in a point, or you're plugging in values and solving the equation for that missing b value. So there's one way to come up with the equation from 2 points. We're going to look at another example, same idea, except in this case our slope is going to be a fraction. So essentially we're going to work through and just kind of see that we can have different representations for our slope. But as long as we have 2 points, we can find the equation, or we should be able to find the equation. So first I'm going to find my multiplier, change in y and change in x. So from 3 to 9, that's a change of 6. From 3 to 12, that is a change of 9. So my multiplier, change in y divided by change in x, equals 6 over 9, which I can reduce to 2/3. Now I need to figure out what my multiplier is, or my b value. Well, the way this multiplier works, this is saying increase of 2 for every increase of 3. So every time the x goes up by 3, the y will go up by 2. I could reverse that pattern then. If I take away 3, then that means based off of my multiplier, I would have to take away 2. This would give me at a position of 0, I would have a y value of 1, which does also happen to be, again, my b value. So it did work out nicely in this case. If it didn't work out nicely, again, I can take a value, so 3, I'm going to multiply it by my multiplier, so 3x times 2 over 3 gives me 6 over 3, which is equal to 2. That means then that 2 plus something has to equal the y value, which is 3. The only thing that you can add to 2 to equal 3 is 1, which gives us the multiplier. So different ways you can work around it. Right? Either reverse the pattern to get back to position 0, plug points into your equation, or basically multiply the x value by the multiplier and find what constant would you have to add. Either way you look at it, we end up with y equals our multiplier, which is 2 over 3, x plus 1. And again, we can see why we would like to keep our fractions as irregular fractions or improper fractions. We don't want to convert it to mixed because we like to see what we change by every time. And we like to keep it as fractions and not decimals because, again, it gives us a better idea. So this one tells me that I'm increasing 2 positions for every 3, or 2 tiles, or whatever the case may be, for every 3 positions. If it was a decimal, it would be telling me I increased 0.6666666 for every 1 position. So again, it's a little bit nicer this way. Another example, except this time we're going to be given a table of values. Or sorry, not a table of values, a graph. So when we have a graph, we know how to find an equation from a graph, right? We can use the rise over run for our slope, or the multiplier. We can find the y-intercept. If we don't remember that, we can always take 2 points and come up with a table. So I have 2 points that are labeled nicely or indicated nicely on our graph here, on our line. And again, they're nice points because they cross a grid line. So I can easily tell the values. We can see this one is 0, 4, or -4. And this one here is 2, 2. Again, remember x and y for your points. So I can take those 2 values, plug them into my table. 0, -4, 2, 2. I'm going to find the change in y and the change in x. So -4 to 2, that's a change of +6. From 0 to 2, that's a change of +2. So I can find my m value, change in y over change in x, which is 6 over 2, which is 3. I can also find my b value. I can see it in the table. I can see the x value is 0. I can also see it from the graph as well. So now I can write my equation. Y equals 3x plus, or not plus, sorry, minus 4. So again, you could get that from the graph as well, right? Doing rise over run. So we go up 1, 2, 3, 4, 5, 6. So you're going up 6 over 1, 2. Again, rise over run, 6 divided by 2, which is 3. And we have our b value. So again, different ways you can figure out the equation of a line. You can always revert back to a table if you find that easier, or if you have a graph and you have nice points, you can use rise over run, which is essentially change in y over change in x, and find the b value. So just some 2 different questions, just to kind of get you thinking. So different things. Still looking at linear relationships, doesn't necessarily focus on the 2-point problem in this case. Nick uses the equation C equals 30n to determine the cost C in dollars for renting a car for n days, where n is a whole number. If Nick can spend a maximum of $200 on the rental, which of the following describes all the possible values for n? So there's different ways we could go through this, but essentially Nick has a maximum of $200 to spend. There's an equation that he can use that tells us the cost C and the number of days, n. So there's different ways you could solve this. You could use guess and check. In A, if I'm using 7, 8, 9, let's look at what 9 days would cost. Well, 9 days, we have C equals 30 times 9. This gives us 270, which is more than we have to spend. So this is too much. Because it's too much, I can't rent the car for 9 days. That means I can cross off these 2 values right here. So just by doing one simple substitution, I found that two of my answers, or possible answers, are wrong. Let's look at something else. If I look at C and D, I have a list of days or possible options for days. 1, 2, 3, 4, 5, 6, and then D has 7. So the only difference in D is 7. So let's see if 7 days works. Because if 7 days works, then D would be all the possible values. So C equals 30 times 7, 210. Okay, nope, too much. So that means D is wrong and C has to be correct. So by doing two substitutions, I can already cross off answers that are wrong and figure out which one is the most correct. Now there is another way that we could solve this, right? I can actually use the equation. C equals 30n. The most I can spend is 200. So that means that 200 would be my cost. So 200 divided by 30n, I'm going to solve this equation for n. 200 divided by 30 equals n. 200 divided by 30 gives us 6.6, which is n. So that means I can rent a car for 6.6 days. But because n is a whole number, that means I would have to round down. And I would get n equals 6. So that means the most days that I could rent the car for is 6. Anything more than 6, I would be over my limit. So again, this is another way that this gives us C for our answer. So just kind of a walkthrough, just because you may, just if you're not sure how to solve the equation, you may be able to plug points in and solve, right? And but just by doing that, we can cancel out possible values. So again, just different ways to solve an equation, and both ways can result in the right answer. If we look at the next one, a class measures the diameter of a snowball as it melts. Information about the diameter at two different times is shown on the grid below. So we have 2 points. If the snowball continues to melt at the same rate, what is the total time it will take the snowball to melt completely? So we have 2 points. We have 0, 24, and we have 520. So there's different ways that we could do this. Right? If I look at my possible answers, only one of them is visible on the graph. So if I put that in here, if this is a linear pattern, this should form a straight line with the 2 points that I already have. Well, by looking at just those 2 points, I can see that clearly D is wrong. There's no way that that would form a straight line. So D is wrong. We just can say not a straight line. Now we have 3 more options. So there's different things that you could do. We could graph this out. We could maybe extend our graph nicely and kind of guess to when the next value, or when it equals 0 for our diameter. The other thing we could do is find our multiplier and just continue our pattern. So we have 0 and 24, we have 5 and 20, change in y and change in x. Y goes down by 4, x goes down by 5, or increases by 5. So m, or change in y over change in x, is equal to negative 4 over 5, which reduces to negative 0.8. But again, this doesn't actually get any smaller into a nice fraction. So I'm going to leave it as the negative 4 over 5. So that means I could continue my pattern. So if I increase by 5 again, after 10 minutes, This brings me to 16. Because I increase by 5, I decrease by 4. Increase by 5 minutes again, 15 minutes, I go down to 12. 20 minutes, 8, 25 minutes, 4, 30 minutes, 0. So that tells me that 30 minutes is the correct answer. I could have gone and looked at my possible values, and well, I could have crossed off, oh no, by going through the table, I can realize, okay, at 28, that's too much. Going down again, 24, nope, that's too much. So this one, you may not be able to cross off too many options right away, but at least you can reduce it a little bit by plotting some of the points. If you extended the graph or had a bigger graph, you could have plotted those points and see which ones form a straight line. But the main thing from this lesson is if we're given 2 points, that is the minimum we need to be able to come up with an equation of a line. Right? We can find the change in y over the change in x to find our slope or our multiplier. We can use that pattern to reverse back to find our 0 value or our y-intercept or our initial value. Or we can kind of use that multiplier and algebraically solve for that y-intercept. So different ways we can go about solving it that we've seen, but the main thing is that the minimum we need to come up with an equation of a line is 2 points.